Greetings to everyone in the session. I'm about to present the work titled Abstract True Push Communication Integrated Style for Rich Web-Based Applications. I'm Nalaka Disanayaka, a senior lecturer in the Department of IT, Faculty of Computing. Dr. Darshana, a senior lecturer from the Department of SE, Faculty of Computing, and Dr. Shanta, a senior lecturer from the University of Kelaniya, are also contributing to this research. I will first provide an introduction to the research, then state the methodology. After that, discuss the derivation of the proposed style, and then mention some evaluation results. Thereafter, I will point out some potential future work and finally list down the publications. Software architecture can be seen as the foundation of any software system, which provides an overall picture of the system to assist in realizing the system. A carefully designed sound architecture is significant throughout all the phases of a software engineering. Architectural style is an abstract description of tried and tested good practice of the generic form of the architecture. Architectural styles are utilized to design the software architectures. The configuration of an architecture explains the relationship among the architectural elements, which are components, connectors, and data, during a period of runtime. When deriving architectures by applying the constraints on configuration, the architectural properties such as simplicity and visibility are induced. This research targets on the systems called rich web-based applications, which is a type of web-based systems. These advanced systems have rich GUIs, which communicate with server using an advanced communication model called delta communication. The rich GUIs together with advanced delta communication improve the user experience. Most of the web-based systems we use nowadays like Google Apps and Facebook are actually rich web-based applications. Rich web-based applications are complex systems and numerous development technologies and techniques are used to develop different elements. Usually the elements of the rich web-based applications and their configuration are defined in an ad hoc manner without proper definitions. Rich web-based applications use push communication to push content from server to clients. Push communication helps to further improve user experience by implementing features like notifications and real-time updates. However, the core technology of web, which is HTTP, is based on request response model. That means it supports pull communication by default, therefore does not support implementing push communication. Still, in rich web-based applications, push communication can be implemented in the form of delta communication. There are technologies and techniques like polling to simulate push communication based on the request response model. Also, there are advanced technologies like WebSocket, which can implement true push communication where server elements push content to clients. The advanced true push communication technologies help to improve performance and scalability, and as a result, the user experience is also improved. The problem in this environment is that integrating push communication into rich web-based applications is complex and also an abstract architectural style to realize the integration of the true push communication into the rich web-based applications is not available. The available architectural formalisms for rich web-based applications are mostly based on some technologies or techniques, hence not abstract, and also none of them support true push communication. We propose to introduce an architectural style named XRework style, which can realize the elements required to implement true push communication and their configuration. Such a style is beneficial since it can provide all the advantages of an abstract style, like offering a framework to design the rich web-based applications, which uses true push communication. The aim of the research is set to introduce an abstract hybrid architectural style which can realize the integration of true push communication into rich web-based applications. This research focuses on the browser-based rich web-based applications and emphasizes on the abstraction of the proposed style. This style should be able to realize the integration of true push communication with pull delta communication as well as non-delta communication. We have set 6 objectives to achieve the aim of the research. This research is mainly a conceptual and qualitative research, and we have selected some methods to align with that. As a research framework, we use the software engineering research framework. We have used the conceptual category of this framework to describe the nature of our research. Out of three approaches, we have opted to extend an existing style to derive the proposed solution. We have selected a style named Rework style to extend to realize the integration of true push communication. For the design process of the proposed style, we used a process with two phases. The first phase focuses on setting the requirements. A three-stepped method is used for that, which had been used to derive the Rework style, which is a published method. The second phase focuses on deriving the proposed style. In this phase, we utilize the method introduced by Fielding when he derived the famous REST style. For the evaluation, we decided to use three methods and triangulate the results. We first used a self-evaluation based on a derivation tree. Then a contextualized comparison is done to understand the effect of the introduced style against the available solutions. And finally, conduct interviews to receive feedback from some domain experts. While studying the push communication enabled rich web based applications and their development technologies and techniques, we have identified the features of push communication. We analyzed them into four distinct aspects as shown on the slide. Based on that knowledge, we continued the study and identified three common characteristics of the push communication based rich web based applications and also three features essential to be developed in the push communication based rich web based applications. Based on these identified features of push communication, as well as the common characteristics and essential features of PC enabled rich web based applications, we derived four features to be expected from the proposed style. Then, based on those features, we set the functional requirements for the proposed style. These functional requirements are utilized as the constraints when deriving the proposed XRework style. Considering the properties of the rework style and the characteristics of the PC-enabled rich web-based applications, we opted to induce these architectural properties as the non-functional requirements. Towards ensuring the abstraction of the style, we set these technical requirements to be satisfied by the XRework style. Having the requirements set, first a formalism named Smart True Push Communication Style is derived. The derivation starts from the null style and the constraints, which are based on the functional requirements, are applied one by one to derive the desired style. The ultimate smart true push communication style is depicted on this slide. This style can realize the push modes and true push communication in the form of delta communication. Then the rework style is extended by merging the smart true push communication style. The resulting formalism looks like this, which is named as the X rework style. After that, some enhancements were identified and applied to increase the simplicity and visibility of the style. To evaluate the derived style, first a self-evaluation is done to identify the properties induced by applying the constraints, which are based on the functional requirements. A derivation tree is constructed to understand the induction of the properties. The derivation tree verifies that the opted non-functional requirements are satisfied by the XRework style. In the next step, a contextualized comparison is done. The context is based on the requirements. The table on the slide shows the comparative values of the satisfaction of the non-functional requirements within the context. The results interpret that the XRework style satisfies the non-functional requirements more compared to the available solutions. We have identified some future work to be followed by the introduction of the XRework style. We have implemented a case study to demonstrate the adoption of the XRework style using a browser-based application. It should be further experimented to learn the adoption of the style into other types of rich web-based applications like mobile apps and IoT-based systems. Since the XRework style can streamline the push communication enabled rich web-based applications engineering, we think that the push communication enabled rich web based applications testing practices and methods can be identified based on the proposed XRework style. Another potential research domain to follow is ritual-based applications designing. A style is used to design the architecture. However, it can also support low-level designing in many ways. We think that it is possible to introduce designing methods based on the introduced XRework style. Also, it is likely to develop libraries, frameworks, and even IDEs based on the XRework style to support rapid application development. In the early stages of this research, which focused on deriving the rework style, 4 journal papers and 4 conference papers had been published. Extending the rework style to derive the X rework style is my PhD work, and I have published 2 conference papers during 2021. That concludes the presentation. Thank you very much for your interest.